Now, as you all know, next week we have the spring break, so no class on the 11th, and we will have class on the 18th. Okay, now what I would like to do is see if there are any questions first. Any questions?
I had questions about the assignment, the reading assignment.
About which assignment?
The papers, chapter 6. Are you gonna go over like the reading assignment?
Yeah, we will be talking about the implementation this
Okay,
evening.
that
Yeah,
I'll read. So thank you.
I will be explaining not all the lines of code, but some of those. Okay.
I I have a question about your lectures.
Okay.
You talked about refactoring and also the fines in the library, but I didn't see that part of the PowerPoint presentation. Was that should
Oh,
that have been?
yeah, that was that was that was a mistake. I omitted it. I mean, I rewrote the PowerPoint, but then I forgot about the refactoring part of it. Anyway, refactoring, what we will do is we will spend some time on it the week after spring break on refactoring. Okay,
Okay,
and
sounds good.
yeah, it is kind of yeah. We're just probably then going to just delay it by 1 week. Okay, I don't have anything on refactoring this evening in the class exercise, so it was an oversight on my part. Yeah, I'm sorry about it. I will fix that when we come back. We will have refactoring done in week 9, and then week 10 we have the exam. So yeah, we may have to abridge refactoring a little bit because there is so much material there, and we also need to cover a little bit of inheritance. So we will be really pressed for time. So I'm going to cut refactoring a bit. Then what I want to do from my part, if there are no more questions, is show you the implementation. What I'm going to show you is essentially the same implementation that I have uploaded, but with a couple of changes so that it probably is a little easier. Some of the difficulty might be a little, maybe some of the stuff may not be as hard as it is in the stuff that I uploaded. I will get to that. I will talk about it when we get there. Okay. So let me first go ahead and share the Eclipse window. I'm going to use Eclipse code, I mean Java code through Eclipse rather than do anything on the whiteboard or anything of that kind. You don't need to do any of that stuff. By the way, I mean, as I said, I will not be explaining every line of code. That is impossible. I will be showing you the most difficult, the more difficult part of the code, and uh, ones that are not really covered by design. Okay, so let me go ahead and share things now. Okay, let me, all right. Okay, the first thing here we are going to look at is the way the user interface and library communicate. Many of these facade methods, the methods that you call in the library, have parameters, and one difficulty is that they are all, many of them are strings, and you can easily mix them up. If you put things in the wrong order, it the, it will compile, but you won't get correct results. And so that is a problem with bugs. The second aspect is something I talked about in the videos. That is, this is not how a library is going to be in practice. You will probably have user interface as an app on a cell phone, or a graphical user interface program on a laptop, or you might just use web access. And the library server would be far away, and you need to communicate over the internet to get to the library. So when you want to send data back and forth, you would like to put as much as possible into one message, because if you send multiple messages, you need to do a lot of work in your local machine. When you send a message, it has to go from your program to the operating system, from the operating system to the network software. Then and all these things have to generate interrupts. There is a lot of overhead. And then the same thing, same set of interrupts and overheads occur at every routing point. If you are sending from here to, say, Seattle, it may have to go through 3 or 4 machines, and everywhere you need to consume some resources, spend some time processing your messages, etc. So instead of sending 4 messages, you might want to just send 1 message with everything in that particular message. Even if the message is a little long, it is okay. So that is why around 2000, people came up with the idea of a data transfer object. So we thought it would be a good idea to put that into this course. So this data transfer object pretty much can have all kinds of things. It is entirely up to you what you want to put in there. It depends on the application. It depends on how the 2 agents want to communicate. So you can throw in all kinds of stuff here. So here is a bunch of fields that a data transfer object has in this application. I'm putting all the string fields of book and all the string fields of member. And actually, this is not really a string field. So this is in addition. This is actually a calendar object, but I have everything as string fields over here. So this will be subclassed into a result object, or a result subclass, and a request subclass. So request is something the user interface creates. Obviously, the word request means something you want the library to do. And the library gets a request object, and then it comes back with a result object. This class is in itself is extremely simple. All it has is a bunch of getters and setters. And I also have something like set member fields. Given a member object, it copies all the stuff to the respective fields in the data transfer object. Nothing very, I mean, like 4 setters in one shot. And I made slight changes here from what I have posted on D2L. And here, I should be doing something else. Okay. Actually, this is not the version I should be showing you. Or it could be. It doesn't really matter too much. It doesn't really matter. I mean, I would like to change some of these from none to something better. I'm putting a none at this point in this version because I don't have a book ID, I don't have a book title, I don't have a borrower, etc., etc. Instead of that, I could put slightly better strings. Like I could say book, instead of none, I could say bad book ID, or book title none. Instead of that, maybe no such book, or book due date, I could say not applicable because there is no which is not borrowed or some such thing. So you could have better strings put in, but that is a very, not a very difficult thing to do. And so this is subclassed, as I said, into two things. One is a request object or a request class. So request extends data transfer. And when you request stuff, there are certain things that are not in data transfer that you want to add. So this is the data transfer object, obviously. A request object is a data transfer object because it is data transfer object is a superclass. But there are a couple of things I want to put when I make a request that are not in data transfer. One is the date on which I want transactions, and the other one is the validity of the hold. So I have getters and setters for those here. And this is a singleton, as you can see. There's a private constructor and so on. Result has a bunch of result codes. So this also extends data transfer. So it has all the fields of data transfer, the result object. And then there are getters and setters for the result code, which indicates whether an operation was successful or not. So if everything went okay, I'm setting result code to operation failed. And otherwise, I try to be a little specific as to what went wrong, then that is captured by all these constants. So this is a fairly simple thing to do. And if you look at this Zoom window is giving me a problem. Okay, let's now go to user interface. Where is it? Okay, I haven't opened it. All right, let me go ahead and open the user interface then. Okay, let's just take a look at one specific, it doesn't really matter what it is, one of the functionalities. Let's pick add member. In add member, obviously you call it when you have to add a member. The program calls the get name method with this prompt. So this will get the name of a person, multiple tokens, multiple words are possible. And you get that string and set it as the member name in the request object. There is only one request object. It is a singleton. Similarly, I get the address and then I set it into the request object. I get the phone number, put it into the request object. And I ship the request object to libraries. There is exactly one parameter here. The advantage is I don't have to remember the order, whether it is name first, address second, phone third, or some other order. I don't have to remember anything. And the library can simply use the getters on the request object to get what the name is, what the address is, and what the phone is. So this way, there is no, or there is less chance of a bug. And the library returns a result object. And if the result code, that is not equal to operation completed, there is an error message. Otherwise, the library has put in the name of the person. Of course, you have it here too, but still. And the ID, which you didn't have. So result.get member ID. So that is how things fly between the two parties. Any questions? Okay. The library is a singleton, and I put catalog as an inner class of library. In previous semesters, I put this as a separate class, and it was a singleton, but it had a problem. I mean, it is not that there was any bug or anything, but there is a little safety issue. If you put the catalog as a singleton outside of a library, user interface can get a hold of that object, and it can wreak havoc if it is malicious. It can go ahead and do things like creating its own book and putting it in, or deleting a book, or changing the book objects in some way. So this way, if you put it as a class inside library, you can make it private, and nobody outside of library even knows this class. It cannot even get a hold of this catalog object. So there is more safety if you hide it from potential malicious code. Otherwise, the code itself is not all that hard. It manipulates a list here. We made everything lists because we didn't want to get into a lot of data structure related issues. We wanted to show the object orientedness of it rather than talk about algorithm complexity or any of that stuff. Similarly, member list is also a private class inside. Only thing is, now I cannot make member list or at least I'm not able to make member list and catalog singletons because of some Java quirks. It doesn't want a static field here unless it is going to have a final value assigned to it and all that. So that was the reason. Otherwise, you can see that if you get the add member request, you are getting a request object, right? You create a result object, and it will have all none in every field, or something more meaningful if you want. And you get the name, address, and phone number of the member, and ship those to the member constructor. Of course, there is a potential for a bug here, because I may switch these two and then still not get a syntax error. Well, that is a possibility. I mean, and then I insert it, and then if everything went okay, I set the result code to operation completed, and set the member fields, copy from the member object to the result object, so that the user interface program cannot modify the member itself. It doesn't get a member, it gets copies of everything, or the string fields that the member has. If this didn't work out, I would set the result code to operation failed and return the result object. So that is how this specific operation works. Any questions before we get into something more difficult? Okay. Now, pay attention carefully for the next functionality, which I am going to show you now, which is getting the list of all transactions that happened on a certain date for a certain member. So this is where you go in user interface when you want transactions on a certain date. So what I do is I ask for the member ID and store it in a request object. Then I get the date for which the transactions are needed and put into the date object of request. And then I call the get transactions method of a library and put this request object, and it comes back with an iterator of transaction objects. And what I do is I get every object, transaction object that is, result.next gives me a transaction object, and that is guaranteed to be for this member on this date. And I print the type of the transaction, maybe book issued or book held or whatever, that kind of stuff, the title of the book, and maybe, yeah, that's it. And then I print something like end of transaction. Fairly simple from the user interface viewpoint. But how is it done inside? It gets a little tricky. Library.get transactions is what we need to look at. What does library do? Actually, that is also not all that hard. When the real difficulty is in a new class and part of member. So this is also not going to be all that bad. So here is where you go from user interface when you want transactions on a certain date. So what it does is, what the library does is, it gets the member ID from the request object and checks whether it is in the list of members. Members is member list. And if this member is null, it returns an empty, it creates a linked list and that is empty and returns an iterator to it so that the user interface doesn't get a null object back. So it doesn't have to check for nulls, which is very convenient. So that is what you do. But in the more traditional, more, what do you call, hopefully, the majority of cases, you would actually have a member. Then you ask the member, give me your transactions on this date. The request has a certain date, request.getDate, and then you're asking the member object for all the transactions on that date. That is where things get pretty interesting. So what we want is an iterator to transactions. So we are introducing a version of iterator that is a bit sophisticated. Obviously, this method returns an iterator to a transaction, otherwise it won't compile. But how is that implemented? That iterator is going to be here. It is called a filtered iterator. So I'm not sending back a normal iterator, the standard iterator. I'm sending back an instance of a filtered iterator. So let's just look at this class and see what it is doing. And then we will see how it is being utilized. So this iterator is an iterator, obviously. And what it does is it needs another iterator. So given an iterator, it will go through every element of that iterator. It keeps getting next, 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 and then it selects certain things. So imagine 100 transactions. So this iterator needs another iterator that gives you all those 100 transactions. And then those are all supposed to be transactions for a certain member, all the transactions for a member, all right? And then out of those 100 transactions this member has generated, this filtered iterator is going to pick maybe 5 or 6 or some such number that fall on a certain date. So that is what this does. This, when you call next on filtered iterator, it automatically skips all the transaction objects that are not falling on that certain date. That is what this is doing. So how does it do it? Well, first of all, you need that iterator. And you need an object The second parameter is an object that checks a condition. It can be any condition under the sun on this transaction. So you can test the transactions for certain properties. Whatever that test satisfies, this iterator will supply. So it doesn't have to be just things falling on a certain date, transactions falling on a certain date, but that is where we are, how we are using it, but it can be any test on a transaction object. So there is a class called predicate. Sorry, it is an interface in Java, in the Java Development Kit, JDK. This predicate is an interface with exactly one abstract method, and that is called test. Okay, so if you are implementing this interface, you have to implement test. So let's see how things flow. When you create a filtered iterator, you have to supply an iterator to a transaction, and you have to supply an object that checks properties on a transaction. So you store the predicate object and the iterator object. So the caller has the collection of all transactions. The caller also has decided how transactions should be selected. So both those things are being shipped. So this object, the real object that is coming here, the actual object that is coming here knows how to test a transaction. And this gives you all the transactions. So you remember those things when you create the filtered iterator. And what you do is we have this field called item that is of type transaction. And this always stores the next transaction that satisfies the test and should be supplied to the caller when they say next. So this is obviously an iterator. Filtered iterator is implementing iterator. So it has to have has next, it has to have next implemented. So when next is called, you will be supplying things from item. So what you do is, of course, if there is nothing more to supply, then this will throw an exception just like all iterators. Otherwise, it takes this value from item, which contains the next thing to be supplied, and puts it into another variable. I called it return value, and we return that. And then what we do in the middle, after copying item to return value, I am moving my pointer or cursor or whatever you want to call it, or reference to the next transaction that satisfies the condition. So after supplying a specific transaction, I want to move and get the next one that is going to satisfy, so that the next time next is called, I will be supplying that. So what is get next item? That is a private method. That is why I have put this in /*/not/**. What it does is it keeps iterating through all the transactions until it gets something that satisfies the condition. So iterator.hasNext, while there is at least one more transaction that I haven't looked at, I copy that into item, and this is the predicate object. It has a method called test. So if this item, which is a transaction, passes this test, I have the right value in item. I quit. Otherwise, I will look at the next transaction and the one after that and the one after that. I'll keep looking until I get something that satisfies my test. If nothing satisfies my test, iterator dot has next would be saying, I don't have anything more to give you, and I will be exiting the loop. And then I will set item to null. So if I run out of all transactions, I will set item to null. Otherwise, I will set item to the next transaction that satisfies the test. So it is not all that bad. And has next for the safe iterator is simply checking whether item is null or not. Any questions? Okay, let's see how this is being used. And I'm introducing something that most of you probably haven't seen, but I know some of you have used, because there is a lot of usage of that Java feature in example programs, so it is worth learning it. I will show you that. I will show you how this filtered iterator is being used. It may look a little mysterious, but it is not all that hard. So let's look at member. In the member class, we have the library calling this method get transactions on date. This is being called by the library, and the library supplies you with a date. And what this does is it creates a filtered iterator and gives it back to the library, which simply gives it back to the user interface. So there is nothing that you do with the filtered iterator either in member or in library. They just give it to the user interface to look at. What does this method do? It creates this filtered iterator, and remember, you have to supply two things. One is an iterator to the transactions. So there is a field called transactions here. Where is it? Here. It is a list of transaction objects. All the transactions this member has created. So going back here, so an iterator of that is the first parameter of the filtered iterator. So this is what the filtered iterator is going to use to get to each transaction. And the second parameter is probably going to look very mysterious to you. I have explained this in the videos, but I will explain it again to some extent. The second parameter, if you look at, say, filtered iterator, it's a predicate object. So normally what you would do is you would implement the predicate interface. So the code that you would normally write would look something like this. I don't think I want to write every letter of it. You would write something like this: public my predicate or some such thing, and perhaps a transaction here implements a public class, right? Public class implements predicate transaction. Or I don't really need this stuff. I can probably get away without doing that. And it is giving me an error because I haven't really imported it. So let me go ahead and import it. And I'm still getting an error because I haven't implemented test. So I need to implement test. So what do I do here? I'm getting a transaction object T here. So I will test T dot on date, you say some date. I mean, I have to have this object. I mean, this is the test. If I get a transaction T, I am saying it is valid if it falls on this some date. So assume that some date is initialized somewhere in this class. That is the idea. But if you think about it, this interface predicate has just one method, test. And I wrote so much code here, and the only relevant things are this condition and the fact that this T is of type transaction, right? Everything else is kind of redundant. Even in that, this T will be of type transaction, the way the predicate interface is defined. So even this type name is understood. So the only things that I am saying is really this condition where T is of type transaction. All these other tokens here that you see, public, class, my predicate, implements, predicate, transaction, etc., all of those things are kind of redundant. You don't really need to write all that. You're writing it because this is a way of solving that problem, implementing that interface. But it is a lot of bloated code. So Java has this shortcut by which you simply, or you essentially write this piece of code. And that is what we have here. Okay, here. Transaction dot on date, and this on this particular date. So what I have done is essentially write this piece of code instead of T. I made it a little clearer, writing transaction. And what is transaction? That is the parameter. So here I am putting the parameter name, and this is essentially the test. And this is the notation that Java requires you to use. If this is the parameter, then the code is going to be this. Evaluate this for the test method, where transaction is the parameter. So if you lift all these things, it is as if you have written all these piece of code, and instead of T, we really have transaction and so on. And so this is also transaction. And this would be basically date. So it is as if all those other things are put in place, except I mean, all these other things that are missing are put in place. And this is what is actually unique about the implementation that Java cannot guess for you. Java can guess everything else. It can, because the second parameter is a predicate, it knows that you will be implementing a predicate. You'll be implementing the predicate interface. So it knows that this has to be a predicate, this whole thing. So it is making you do less work. This is called a lambda function. And it is used extensively in Java. So you should know that. Otherwise, you will be really wondering what those programs are doing. So this is essentially, this can be interpreted as having, as implementing the interface, writing the method that you need to implement, and putting this as the parameter to that test method, and putting this as part of the if statement. All of that done in a very short manner. So that is a little difficult, but there are so many difficult things about programming, and so many cryptic things that one needs to learn in languages. You might come across this in in the programming language theory class 365. Lambda functions is something that is used in other languages too, like Lisp and other places. Any questions? Okay. Then the next one is I have implemented a couple of methods that are not really part of the analysis. Okay, let me show you that in the library, or actually in the user interface too. Let's look towards the end. There is a, yeah, there are two methods. One is get members. It is kind of a little strange that there is no functionality to list all the members or all the books. So I have put in that functionality here. So what it does is, it's when you write public void get members, you call the library to get all the members, you get an iterator, but it iterated to a result object, not to the member objects. Because if you give this user interface an iterator to a member, it is able to get hold of every member object, and it can actually destroy the integrity of it. So we are being suspicious of user interface. So we are only giving copies of the member fields. So you are not getting an iterator to a member, you are getting an iterator to a result. And how does it work? You get this iterator to a result, and you iterate on it, get every result object, and you print whatever you want from the result object, like name or address, etc. of the member. That's it. But how is this actually carried out? How do you convert a member object to a result object? That is interesting. Let's look at that. I have this class called a safe member iterator. So this is another iterator. What it does is it takes an iterator to a member. Okay. So it takes a member. To construct this, you need an iterator to members. And this is going to produce the result object. So when you call next, it is going to give you a result object back, not a member object. So it is actually very simple if you look at it. Given this iterator to all the members, it checks if there is a member that you haven't seen before. If so, it gets it here and then tells the result to copy all the member fields. That's it. So give this safe member iterator an iterator object to all the members, and that safe member iterator you are going to use and you are going to call next. When you call next on the safe member iterator, it is going to get a member object and make the result object copy that member object to its fields. And if there is no more member, this would return false, and you will be returning false from this hash next. So the hash next is calling iterator.hash next. Whatever it is telling you, you will be telling your user. So it is extremely, I mean, it's not very difficult actually. You're hiding the members. If somebody asks you for the members, you're going through every member and then copying it somewhere and then giving the copy. That's it. So think about it that way, all right? You ask for some document from somebody, all right? It's a sensitive document. So what they don't want, maybe suppose there is an old precious book from the 15th century or some such thing, you know, or 17th century, whatever. It's very, very precious. And somebody says, I would like to read it. and you are the librarian, you say, no, 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 I'm not going to give it to you because you are going to spoil this book. So what you are going to do is take each page, photocopy it, and give the photocopy, right? That is essentially what you are doing. Um, Take each page of the book, right? Get each page of this precious book, put it into the photocopier, and ask it to copy. And then you give the copy to the user. Then take the next page, copy it, keep doing it. And eventually, when this guy, when your customer says, give me the next one, you will look at the book. Is there one more page that I haven't copied? The answer is, if the answer is yes, you will say, yeah, I will give you one. Otherwise, you will say, no, that's it. There is nothing more. And of course, if that fellow says, give me the next one, then you are going to just throw him out. Right? That's what you do here. Similarly, there is a next, safe book iterator. If you understand this, the other one is identical, except that it is working on books. In the version that I uploaded, version 1, there is actually a single class safe iterator, and I thought that was too much. I would have preferred this, but it is putting everything into one class, and this is not easy to follow.
Okay, I have a question, Professor.
Yes.
So this safe member is actually using the data transfer class then?
Yes.
Okay, all right, thanks.
Yes. Very good observation. Yes. Basically, the result subclass of data transfer, right? So it is used for almost everything to supply stuff from the library to user interface. And the thing is, you are not trusting the user interface because it comes from that user interface is coming from a different world altogether. I don't trust that. I only trust things in the business world. That that is the idea. And this class. Actually, the class exercise tonight is based on, I'd asked you to look at this class rather than the safe member retreat or a safe. This is putting two things into one class. But the thing, if you look here, it is a generic class, so you have to say what you are creating, whether you are creating a book or a member, whether it is a safe member iterator or a safe book iterator, and then you need to supply not only the, where is it here? When you create the safe iterator, you need to supply an iterator to a book or a member, just like the other one, but you also need to supply one of these two public static final types. If you're supplying a book iterator, then you need to write book, safe iterator dot book as the second parameter, because I'm using polymorphism to copy to member fields or book fields. So there is a little bit of difficulty here. It is a bit mysterious what is happening here. I'm using polymorphism. If I'm getting a book object, I'll be going to the book. I am having some inner classes here, safe book and safe member. So if I get a book object, I'll be using this copy method. If I get a member object, I'll be using this copy method. So it is a bit mysterious, and you should take a look at it while doing your class exercise. If this is still not understandable at that time, ask me if you want some more explanation of it. Okay, that is pretty much what I wanted to say. Of course, there is a lot of other code, which, there's a lot of straightforward code. 70% of the code is very straightforward because they are all fields and with getters and setters, nothing else. The real difficult code where there is some interesting stuff going on is mostly in the library class. And the library class has those facade methods, and some of them are also um, pretty what you call routine. they are not short, but they are routine. Like if you get a member ID and a book ID, you check whether the member is there, if the book is there, etc., etc. Lot of validation before you actually do something. Okay. So you'll get a chance to look at a lot of this code this evening. Okay. So you have a lot of multiple choice questions and true false questions, and maybe one multi-select question, a couple of multi-select questions. I don't remember exactly. So you should, you'll have to download this and look at the code. That is the purpose of this class exercise. Have you look at the code to the extent it is possible in one evening. Any other questions before we create the breakout rooms? Anybody?
Is it possible to go over the hold list class?
To go over what?
The hold list class?
Okay. Yeah, the whole list class, I can show you a little bit. Yeah. Mm. The hold list class is a custom class, unlike the list of transactions or the list of books borrowed by a member, because you don't need to do anything tricky in those things. But here we have a whole list class. This is used in both book and member. So there will be many instances of this created. So whenever you have a member creating a hold, that hold object will be put into this collection, books on hold. And when you create, and at the same time, it will also be inserted into the holds in the corresponding book. So the hold list class has a number of methods. If you create a hold object, it puts this into the holds collection. That is, I put it as a linked list. Keep things simple. Then given a book ID, I want to go through the list of holds and then delete the hold for this book. So this is coming from a member. A member says, I want to remove the hold for a particular book. Then this is what you do. And we have a list iterator here, which you may not have seen before. A list iterator is an iterator, but only thing is it has more methods. You can go back and forth while iterating. And why we are using that here is because, excuse me, we are using it because we want to remove, we want to go through these books, through these holds. And the moment you find something that matches the book ID, if you find a hold that is for a book with this book ID, you want to remove it. If you do it on a normal iterator, you will get a nice crash at that point. Whereas with a list iterator, you will not get that. Otherwise, there is no need for a list iterator, right? An iterator will also go in the same order. So there is no need, so the order of iteration is not different. Only thing is here, I am using it because I have to remove it when I find it. And there is a corresponding way to remove a hold given a member ID. So typically, when you remove a hold, you will be removing it from both lists, right? So you will be removing it from the member, and you will, from the member, and then you will be removing it from the book. Given a member ID, you want to remove it from the book. So you have pretty much the same code, copy and paste, and just change a little bit here and there, all right? Like this gets the book object and then gets its ID. This gets the member object and gets its ID. Then there is this method get next valid hold that also removes stuff. So this goes through the holds in the for the book, and then if it finds a valid hold, it returns that. Otherwise, it removes the removes it, because that is invalid, right? So it may remove many multiple holds. It may remove everything, right? And then it returns the next valid hold. But of course, it may have removed everything, in which case it would return null. And there is an iterator method, and this simply checks whether there is a valid hold on it. That is that. Anything else? Okay. If you can think of something, let me know. I will stop recording now, and I will create the breakout rooms. And remember that there is no class next week, but I will be looking at my email, maybe not continuously, but at least once a day, or maybe a couple of times a day, unless I'm really feeling lazy. And I will be available for appointments if you want. I'll be, I mean, so just let me know if you are getting stuck with your project. I'll be available, but there is no class. Okay, I'm going to create the breakout rooms. It's going to take me a while because I have to do it by your groups. And all of you, please stay back after the class exercise, because I want to speak with you about your project, right? So just don't leave. Okay. Bear with me, please.